There are a lot of mysteries concerning Mars, especially its great transformation from water to a huge mass of dry red soil, which gave it the iconic name, the Red Planet. Due to its bright appearance, it is quite easy to notice this planet when amongst the other celestial bodies. Let's just say it calls out to the naked eye. The atmosphere on Mars is almost the same as that on the Moon and the polar extremities of Earth. It is home to the largest volcano and also the highest recognized mountain in the multiverse. Now, isn't that something? Among the numerous countries that would give anything and are willing to spend millions of dollars to have a research-driven yet adventurous ride to Mars is China. Just like most other space trips, the trip to Mars is quite expensive and requires a lot of preparation and calculations. However, the most challenging part of going to this planet is the environmental difference between Earth and Mars. China National Space Administration, CNSA, launched a robotic spacecraft on the 23rd of July, 2020. The spacecraft, Tianwen-1, was named after a very prominent poet in China who went by the name Chu Yuan. The name loosely translates to Questions to the Heavens, which is a fitting representation for China's thirst to discover nature's truth and discover unknown facts about the Red Planet. China has achieved an impressive feat already. Today, they are the first country that has tried releasing a rover after orbiting Mars during its first trip. Having launched the spacecraft months ago, a very vital question comes to mind. Why is China's Tianwen-1 still not landing yet? Tianwen-1 will not be landing anytime soon, at least not in May or June, because the spacecraft has to properly examine the appropriate landing site before landing. Until then, it closely studies the targeted landing site, Utopia Planitia, and this site has been under strict observation for a month or two. But before we continue, it is important we talk about China's impressive spacecraft. The spacecraft is reported to have a total mass of about 5 tons, making it one of the heaviest crafts launched towards Mars. The spacecraft successfully carries about 13 pieces of high-end space equipment, all of which play a major role in powering the spacecraft. The components of this colossal spacecraft include a lander, a rover, an orbiter, and a deployable camera. The lander is set to utilize its propulsion to ensure a smooth landing on the Martian surface. If the landing is successful, the rover will be deployed by the lander. You might be asking yourself, are there any risks? Well, to answer that question, there is a risk of an explosion if the speed of the spacecraft is not monitored. Once a soft landing is made, the rover begins its exploration. The rover is built to explore the Martian surface for about 90 sols. For those not familiar with the space lingo, sol is a unit used to measure time on Mars. Technically, a sol is a Mars day, and it is slightly longer than 24 hours. The orbiter is designed to serve as a means to transmit telecommunications back to the team on Earth while the rover's main mission is still in progress. It will achieve this by positioning itself in an orbit suitable for more accurate observations while still maintaining the role of transmission. The deployable camera is a small satellite built with 2 cameras that can take high-quality photos and maintain a radio link with Tianwen-1. However, did you know that the Tianwen-1 is not China's first attempt to approach Mars? China combined resources with Russia to gain entry to Mars's orbit in 2011. Russia's spacecraft, Phobos Grunt, was accompanied by a secondary craft, Yinghuo-1. Yinghuo-1 was supposed to be China's first Mars orbiter, but the mission was not successful in the long run. The spacecraft was stuck in Earth's orbit and eventually returned to Earth in 2012, which prompted China to commence a solo mission to Mars. Tianwen-1 requires a large amount of preparation and calculation as its structure is more complicated and was built for a solo initial approach. Now let us tackle the question, what is the main goal of Tianwen-1? As stated earlier, the past presence of water on Mars is quite intriguing and worth investigating, and this will be one of the main goals of Tianwen-1's explorations once the spacecraft lands on the surface of Mars. It will do this by examining the current state of water on the Martian surface, as well as the morphology and geological structures of Mars. The evolution and possible causes of the internal structure will also be examined, and this will be done by analyzing the topography of the Martian surface, also generating accurate data from certain terrains such as the relief volcanoes, glaciers at the poles, and dry riverbeds. The features of the surface and progressive layers of Martian soil will also be studied. The spacecraft will also study the types of rocks, as well as their compositions, and also the sort of elements and minerals that can be found on the Martian surface. The magnetic field on Mars, as well as the internal distribution of mass and field gravitation, will be examined. This means that almost no stone will be left unturned in China's space exploration project. How does China aim to achieve this? To answer that question, we must first understand that the Tianwen-1 was specifically designed to conduct a Mars exploration. This means that every technology on the spacecraft was initially designed to fit this agenda. First of all, the medium-resolution camera comes with a resolution of about 100 meters from a 400-kilometer orbit, a high-resolution camera with a resolution of about 2 meters from a 400-kilometer orbit, and a Mars mineralogy spectrometer designed to identify the elementary composition. The spacecraft also includes the following: a Mars magnetometer to analyze the planet's magnetic field, an orbiter surface radar for the surface analysis, a Mars energetic particle analyzer for the Martian soil, rocks and mineral analysis, a Mars ion and neutral particle analyzer also targeted towards Martian surface analysis, a Mars surface magnetic field detector, a ground-penetrating radar built to view about 330 feet beneath the surface of Mars, a Mars meteorological measurement instrument, a multispectrum camera for sharp images, a Mars surface compound detector designed to utilize both infrared spectroscopy and laser-induced breakdown spectroscopy for efficient Martian surface analysis, and a navigation topography camera to take images. As regards the landing, Utopia Planitia was selected as the landing spot for the spacecraft, and this is not without reason. The surface of Mars is not very smooth, as it is marked by rocks and rough edges in the forms of minerals. Rocks easily appear on Mars owing to the action of wind, which makes Utopia's topography a bit scalloped, consisting of shallow and rimless depressions. However, Utopia Planitia is a very extensive plain within Utopia, and it is devoid of irregularities, such as rocks and unexpected depressions, which make it the perfect landing site. Hence, if all goes according to plan, Tianwen-1 is going to have the smoothest landing. Why can't Tianwen-1 just hasten its landing? Tianwen-1 cannot rush its landing on Mars before its assigned time. A lot of preparations and calculations have gone into choosing the perfect landing time for the spacecraft. The spacecraft also has to spend quite some time examining the target landing site to ensure it makes a safe landing. The examination of the landing site can take more than a month to complete. Tianwen-1 is presently in Mars's orbit and currently conducting this examination while relaying high-resolution images of the site back to the team on Earth. The landing is very crucial and must not be rushed. Some countries have released several orbiters before making a successful landing on Mars. Therefore, Tianwen-1 must be very careful and strategically plan its landing if it is to make a soft landing on its initial trip. This places a huge pressure on the massive spacecraft. Although the space team is not releasing much information about their craft, a lot of expectation is placed on the spacecraft. Tianwen-1's time for landing is quite fitting as it is within the launch window, which is about 26 months. During this period, Mars and Earth will be in alignment on the same part of the Sun. It is important to make the trip to Mars during the launch window as it will reduce the amount of rocket fuel and time spent. Tianwen-1 will be able to start the trip within the launch period, thereby favoring its total cost and reducing the time it spent to get to Mars's orbit. Tianwen-1 will be able to eventually land on Martian soil once it completes the evaluation of its landing site. The landing step is the most crucial in interplanetary missions. This is due to varying atmospheric pressure once it enters the planet. Maneuvering the speed of the spacecraft in low atmospheric pressure could pose a problem if not properly calculated. Once the craft is ready for landing, it will commence the process promptly without further ado. Of course, there are other spacecraft involved in Mars' space race. They include the United Arab Emirates HOPE and NASA's Perseverance. The United Arab Emirates orbiter, known as HOPE, has successfully reached Mars' orbit, while NASA's Perseverance rover has made a soft landing on Martian soil. Humans have been completing interplanetary missions for quite some time, and it is only natural that we learn from our past missions. Also, things are constantly changing on Mars. Mars was previously known to contain water, but now, not so much. The previous probing of the red planet has showed that water is contained as ice on Mars at the south and north poles, though it is only visible at the North Pole. The ice volume is reported to be sufficient enough to completely submerge the entire planet to a height of about 115 feet in liquid form. That is a whole lot of ice. Ice was also discovered beneath the Martian surface. The immense amount of ice found underground the Utopia Planitia region is equivalent to the amount of water found in Lake Superior. Lake Superior is Earth's third largest lake by volume, with an impressive volume of 12,000 kilometers cubed. It is quite a marvel that the planet, which might have had extensive amounts of liquid water, now contains water only in ice form. there are likely possibilities of the Martian surface and the surface temperature being favorable enough to support liquid water in the past, but the present atmospheric pressure of Mars cannot support the liquid water on the surface as it is quite low. Was there any form of life on the planet in the past? Is there current life on the Martian surface? Can the Martian environment even support life? How are the Martian conditions different or similar to that of Earth? We are all eager to find out the answer to these questions. Make sure to hit that subscribe button and smash the notification bell to get notified when more news on Tianwen 1's voyage is released. Thanks for watching!